Assalamualaikum and hi. Welcome to our video about our presentation for CAD/CAM subject. Our product of choice is a motorcycle sprocket. These are the members of our group. This presentation will be split into 4 parts. First, introduction, then design, followed by machining process, and finally the final result of our CAD/CAM presentation. A sprocket is a profile wheel with teeth or cogs that mesh with a chain, track, or other perforated or indented material. The name sprocket applies generally to any wheel upon which radial projections engage a chain passing over it. After going through many choices, we chose sprocket to be our object in our mini project. This is because in manufacturing a sprocket, it uses multiple manufacturing processes such as facing, drilling, pocketing, and profile contouring. During designing phase, it is important to come up with the best possible design. This is because the 2D sketch acts as a basis for further processes. The design and constraints have to be accurate in order to achieve the best possible outcome and quality of the manufactured product. After several corrections and addition to the design, this is our final design for the sprocket. Notice that in the design, the constraints have been set so it will be easier to undergo the next processes. To start the machining operation, the first step is to enter workbench, then click on start, and then machining, and go to lathe machining. The lathe machining workbench will appear. Select manufacturing program 1 in the tree to make it the current project. Click Tools Change Point 1 to change the drill size. Step 2 is creating facing and pocketing operation. Select the facing icon and then the facing box should appear. Next, select the pocketing icon. The red status light on the tab indicates you must select the pocket geometry in order to create the operation. Right-click the red bottom in the icon and select Contour Detection from the contextual menu. Click the red bottom area and then select the bottom of the pocket. Step 3 is assigning a tool. Double-click the profile contouring operation in the program. Then in the Tooling tab page, select the Tool tab. Enter name of the new tool. Assign the desired parameter of the tool and click OK to accept the new tool. The program is automatically updated. Step 4 in machining operation is creating a drilling operation. First, select the drilling icon, then the drilling dialog box will appear. Select the red hole depth representation in the sensitive icon. The pattern selection dialog box will appear. Select the cylindrical feature of the first hole and then do the same thing for the second, third, and fourth hole. Double-click to end the hole selection. The drilling dialog box replaces the pattern selection dialog box. Double-click the jump distance parameter in the sensitive icon, then enter the desired value. Next, do the spot drilling, and finally set the diameter to drill. This is the end product of spot drilling. After the end of spot drilling, step 5 is changing the tool to make a pocket. The next step is to change the tool to start the finishing process by entering the name of the new tool. Now change the tool again to make the inner finishing. This is done by entering a new name for the new tool. Run the simulation to see the final output of the program. This is the final output of our program. By looking at the object manufactured, it shows that our program and design work well in producing high-quality products. By using multiple manufacturing operations, the complex object can be produced if the requirements are achieved. Thank you.